What's going on, guys? Welcome back. In today's video we're going to do healthcare system exploitation, and to demonstrate the purpose of this video I'm going to use a machine recently released in TryHackMe. The machine name is Plotted-EMR. Now EMR stands for electronic medical records. So we haven't done any work like that before on exploiting healthcare systems. Healthcare systems are very popular these days, as you know, and they are used in every healthcare organization to organize the diagnosis and treatment of people. So the system that we will be going to exploit, the name is OpenEMR. OpenEMR is an open source patient or electronic medical record. As you can see, EMR, E stands for electronic medical record. These systems are very popular these days, as I told you, as it is used to store patient information, organize treatments, and perform diagnosis. So basically, if you are into healthcare, or if you work in healthcare, or even if you are an IT who works in healthcare system, you may often hear the word PHI. So PHI stands for patient, P for patient, H for health, and I for information. And the most valuable asset, or the most valuable information found in any healthcare system is the patient information. It contains information about the patient, such as their credit card numbers, could be there. It may not be, it may be, or it may not be. It depends on the system. Diagnosis information, like medical information, you may find that in the healthcare system. Medical info, and also you find other identifiable information such as name, surname, and country of living, neighborhood, whatever. So these information are very sensitive, and if an attacker had an access to such system, they would use this information to conduct identity fraud, or they could sell this information on the dark web. That's why there was something called, or the standard was emerged to organize the storage of such information. The standard name is HIPAA. You can research more about what's HIPAA. It's actually a standard in the United States issued to organize the storage of patient information. Namely, it stands for Health, Insurance, Portability, and Accountability Act. It has two main items: the security and privacy. These two items are concerned with patient information. So basically, security aims at protecting patient information at rest and in transit. Most probably, you will see it aims for applying encryption on patient information, and privacy to protect the identifiable information such as the medical information, the name, surname, country, etc., and also if there is financial information. So imagine now if an attacker was able to exploit a healthcare system and get access to such information, the corresponding firm or healthcare organization would be fined by HIPAA standard and pay a penalty. So it's not a joke to get your system compromised in the healthcare industry. Not only in the healthcare, actually, most probably in finance, governmental industry, etc. So that's the basic principle of healthcare systems and the security behind it. Now in this video we're going to use OpenEMR. It's an open source electronic medical record. In the scenario here, and the plotted THM or plotted EMR machine, there is a vulnerable version of OpenEMR. The vulnerable version allows for admin access, which gives the opportunity to conduct remote code execution. Basically, in the admin access here, we need to create a new site. Okay, once we create a new site, we will open new records in the Mysql database. These records will be used to perform remote code execution. Once we perform remote code execution, now we will make the jump from here to here. Linux privilege escalation. After we get foothold, the next step would be to conduct privilege escalation. So the first one is we will locate a cron tab. There is a job running in there. We will exploit that. And once we exploit that cron job, we will be given access to a new shell. Okay. This new shell is with a new user. But the new user here is actually not privileged as root, but it's more privileged than data. We will find a PROL library that will enable us to change permissions of the bin bash in order to give us root access. So that is the brief about today's video. We will jump now to the practical part for more demonstration. So this is the machine, Plotted-EMR. Everything is plotted, and in this machine we're given introduction and then the compromise section. We're required to find 3 flags, user, root, and 1 flag that you will find in the web server directory. As you can see, I forgot to provide user flag. I will provide it now while doing the challenge. Don't forget to deploy the machine and get the IP address. Make sure the IP address is popped up. Copy the IP and start your Nmap scan. As you can see, the Nmap scan hasn't finished yet. As always, I'm not gonna waste your time and wait for the Nmap scan to finish. I'm gonna jump directly to the ports that we will deal with. By now, I know every one of you now know how to do Nmap scan, so it's not a brainer. Let's now first go to the OpenEMR page. So the first port is 8890. In this port, it serves the default page is Apache. But if you do directory search, use GoBuster, you will find that there is a page /portal. I'm skipping the repetitive part of every scenario, since you must have known by now how to do directory search and reveal directories on the web server. So this opens a login page. The login page to open the EMR dashboard. We only have username, password, and the language to select. So basically, the first thing we would do here is to try to find the version. Let's take a look at the page source. Sometimes the page source reveals information about the version of the software, but in this case, you won't find the information, or you won't find the version number. I just mentioned that in the case because it's the methodology to do this. So now we close this one. Right now, all we have to do is to try the default credentials, admin password won't work. All right, since we don't want to waste our time with trying default usernames and passwords, let's now turn our attention back to the Nmap scan. So the Nmap scan reveals several open ports, except the port that I showed you here, 8890. Why? Because I canceled the -p, or I canceled the scan for all ports to speed up the scan, and I only opted for -sv and canceled the ping scans. So as you can see, I revealed these ports. If you do the scan with -p-, you will reveal the remaining port 8890. As you can see, we have several other ports. We have 21, FTP, 22, SSH. We have another web server running on port 80, and we have the Mysql Server running on port 5900. Let's now take a look at the port 80. See what kind of page is there. It's a default web page. Of course, as I told you earlier, you can always run directory search, GoBuster, DearBuster on this page and reveal the other directories. But to save you time, I tried this. No meaningful stuff you will find here. You might find a couple hints, but since we're doing the videos for the purpose of real pen testing, I'm gonna skip this part. So, skip this one. SSH, no actual credential we have. FTP. Alright, so FTP, let's see, is anonymous access allowed? It is allowed, and you are automatically logged in. Alright, let's see where we are. So / is the current working directory. ls-la And we have, look at this one. Let's cd it to this one, ls-la, nothing. So no files in here, but there is this one. As you can see, we have 3 dots. It could be directory name, cd 3 dots, ls-la, and here is a file, urdetermined. Get urdetermined. Alright, exit, ls get urdetermined, cat urdetermined. So, sorry but wasted your time. Yes, you have. Here is something for you. A YouTube video. Wait, I will give you a hint. See if you can access the admin account. So again, we're back to the OpenEMR, where we need to access the admin account in order, as I told you, to reveal the actual version and to see if this version is vulnerable or not, so we can reveal the possibility of conducting remote code execution. So this hint came with nothing new. Actually, we knew we need to access the admin account in here. It's very easy to just take it as a hint. Anyway, this was for FTP. All right, back to the Nmap Scan. We have 5900 for the MySQL Server. Let's try to log into MySQL Server and see what we can get. So MySQL-u admin, or it could be actually the hint here. It could be for the MySQL, right? So the hint didn't work for the OpenEMR. Let's try the hint with the MySQL. Maybe you are allowed to log in without supplying a password. So here, only one thing to change is the IP address. Yeah, the part that I hate the most is picking up the IP address every time. So paste. I know I can add it to the host file, but I'm just too lazy to do that. And that's right. The hint actually pointed us in the right direction. We actually have an admin access to the MySQL server. So show database. We have 3 databases: information, MySQL, performance schema. Now if you use MySQL, and reveal the tables, we have these tables. The methodology always is to reveal the records in the table which might contain sensitive information. So we take a look here. The typical one is the user. So select star from user. So now we reveal all of the columns in the user table. We have host, user, password. Take a look, we have localhost, root, but there is no password. Again, admin, but there is no password, right? So what you can do here, you can add your own records. You can add a user with password and give it all privileges. But for what? We don't have an actual use for now, but we will keep in mind and take a note that we can now control the MySQL server and add records. Most probably, the OpenEMR uses this database. So you might be asking me, what if I try the admin without password in here on the OpenEMR? It's not gonna work. Login. Nah, it needs password, so it didn't work. Anyways, now that's all what we have for now. If we go back now to Nmap Scan, the only remaining port left is this one. And we know we have nothing in here. So let's start searching for exploits. Okay, so new tab, make this bigger, search, exploit, OpenEMR. And we have several exploits. In a production environment where you are doing a pen testing for your client, don't go ahead and just try every single exploit against the target. It will probably disrupt the business work. Operation of this program. So what you're gonna do here, if you're not sure about the version, you're gonna, in a real scenario, I'm saying, you're gonna clone the target, including the software, into a new virtual machine and host it on your machine or any machine you have, and then try every single exploit. Okay, let's take a look. So we have RCEs, remote code, authenticated remote code execution. We have several vulnerabilities in here. So the one that worked is this one, 5013. No, this one, 5013, the Python one. So what does this exploit require? You can download this exploit. -m in this command, and once you issued the command do ls, this is the exploit. If now we cat the exploit for 5, okay, Nmap Scan, no need for Nmap Scan anymore. I'm gonna just close this one. All right, title OpenEMR 501.3. Again, we don't know the version yet, we're just trying. Remote code execution authenticated. So this one would only work if you have authenticated access, which we don't. Now here we come to the next vulnerability that you will uncover by doing research. Okay, just research on Google OpenEMR vulnerabilities and you will definitely come across this PDF report. This PDF report outlines a vulnerability in the version also 5013. Luckily for us, this version will allow us to have authenticated access. If you read here, patient portal authentication bypass. An unauthenticated user is able to bypass the patient portal login by simply navigating to the registration page. That's the first step. And modifying the requested URL to access the desired page. So when you go to the registration page, right, and instead of pointing to the registration page, you're going to change the file pointing to the registration page to point to one of these files. Get profile, get problems, get patient documents. In this fashion, you will reveal information about patient appointments, payments, messages, as if you had admin access to the portal and full visibility on the what's going on the portal. So you can basically access all of these files. Additionally, you can access the admin and setup file as well. And here it shows you how to do that. But in the scenario we don't have a registration page. Even if you do directory search, directory buster, and try to reveal hidden directories, you will not find any registration page. So what to do in this case? We can try these pages in here. So instead of interface, we can try to access the pages using this fashion. So portal / say admin.php. As you can see, it's revealed the current sites the OpenEMR is using. So we have the default site, database name OpenEMR, and this is the site name, and this is the version. So finally, you reveal the version by accessing the admin.php. Again, how do you do that? You just take a look at the report here, and you will understand what I mean. All right. So let's take it from here. Close this one. I'm gonna put this link in the description of the video. Back, /admin.php reveals the current sites we have. OpenEMR allows you to create multiple sites for ease of administration and collaboration. Now, the actual site in use now is this one, default. So if you create a new site now, okay, maybe you will have a chance to create a new site with the new credentials. So add a new site, change its name, make it test version 2, continue. All right, here you have two options, have set up created a database. I have already created the database. So the first one, during the setup wizard, it will create the database credentials and will ask you to create your own username and password. This one, I have already created a database. If you select this one, what you need to do here, you need to go back to the MySQL access. Here, create a username, create a database, grant the username all the privileges, and then select this option. Once you select this option, you will be required to enter the information of the user that you have just created in the database here. Okay, now the easiest option is to go for this one. Let the wizard do everything. So have setup create the database. Continue. Alright, here we go to the information. Server host, we change this one to the IP address of the machine. Server port, it is the MySQL port, it's 5900 as per Nmap Scan. Database name, leave it as OpenEMR. Login name, you can leave it as OpenEMR as well, but we will change this to OpenEMR v2. The password, here enter your required password. So let's say password 123. Name for the root account. So by default it's root, but if you remember, we logged into the database with the username admin. So change this to admin. Now since we logged into the MySQL database or MySQL Server without supplying a password, we're going to leave this empty. We don't care about the security of this database. We are actually hacking the database. So going back, source site. It's actually cloning the template of the default site, so we can't change this option. It's actually preferred option to keep it as is. Initial user admin. Now this user will be used to access the dashboard. So change this to admin v2, for example, and the password to password 123. Alright, so the only thing you need to remember is the admin username, also the user password that you created. Now have the setup create finish the process. Click on continue. So what do we have in here? Creating site, okay. Database, okay. Reconnecting as a new user, error, check your login credentials, unable to connect database at OpenEMR v2. Let's go back. Let's change this back to OpenEMR as it's preferred. As you can see, OpenEMR recommended. Okay, password 123, and the password here is 123. User host name, change this to the IP address and continue. OpenEMR has already been installed on this site. Okay, we're going to need now to create a new site since we screwed up the first one. So back, test v3. $5900. Here it is admin. OpenEMR. Okay, password 123. Again here this password is password 123. And here admin v2. Alright, continue. Unable to execute SQL, create database OpenEMR character. Oh my goodness. OpenEMR 2. Password 123. Password 123. Okay, this is actually getting boring for $5900. OpenEMR v3. Password 123. Admin. admin v2. It's gonna complain now. Admin v4. Okay. Password 123. Let's see now. I think it's working now. So once everything is finished, click on continue. Now all of the database records have been created, including the username that we have just created for the new site. So admin v4 and password 123 are the new credentials we need to access the new site. Continue, continue, continue. All right, so what we do now, we're gonna click here to start using OpenEMR. No thanks. Take a note of the URL. See here, interface, login.php, site equal test before. Since now we have created a new site, we ended up now with two sites, the default one and the test before we have just created. Let's go ahead now and log in with the credentials. Admin v4, password 123. And now we have administrative access to the dashboard. Now we can take a look at the appointments, we can take a look at the patient information, also modules. We have full access now to the healthcare system. Now you have officially screwed up the hospital or the healthcare organization. Alright, what to do now? If you remember, we did the authenticated access actually only to have it as a piggyback for the exploit to work. Now back to our research here. Okay, this is our exploit. Now we have authenticated access. We can now perform remote code execution. Now taking a look at the exploit, this is the usage. Python OpenEMR RCE, define the URL, username, password, and then the command to execute. Here, as you can see, it gives bash shell. We're going to use this one. Let's copy this one. Alright, before doing anything, there is a line that needs to be changed. Guess what it is? Scroll down. The line that defines the site. Alright, as you can see here, the site name, our site name is test. Let's go back. Test v4. So we're going to need to change this one. Test v4 instead of test v6. And you're good to go. 904. So go to the line. Alright, here it defines the site. So we can change it to test v4. And let's make sure it's uppercase. Yeah, it is uppercase. And that's all what you have to do. So now Python 4.5. Alright, I think I remember I copied the command. Alright, here it is. So what is my IP address? This is my IP. Alright, so here change the IP address to your own IP. And the port to the port 5555. Okay, so -u is admin v4. The password is password 123, and the URL is, copy the URL all the way until you reach the word portal and place it instead of this one. Of course, change the name of the script 45161.py. Alright, before you execute, make sure you created the listener. nc-ldb 4545. All right, go ahead. And now we receive the foothold. So now we perform the RCE, and now we are inside the box. Who am I? The regular dub data. Okay, what to do now? Next, we will do the privileged escalation. Of course, we can grab lin piece, all right, and execute lin piece. It will point you in the right direction. What's the right direction now? The right direction is to look at the cron tab first. So if we cat etc cron tab, so in the cron tab we see all of the jobs running. Take a look at this one. It's running as plot_admin. What to do? It goes to var www.html portal config, and it performs rsync with -t. We used wildcard asterisk. It copies the website files located here into a directory called backups. So what it does, it takes a backup of this directory, all right, and copies the backup into a directory on the local machine on the home directory called backup. Now rsync actually is a tool is used to perform backups between remote and local sites. So if you want to perform backup, you can define first the source. The source here is the website, and the destination is the backup directory on the local machine. That's the function of rsync. Now rsync by default has an option called -e to perform system commands. -e, where is the -e? Let's see here. -e, where is the -e? Okay, why do we do this? Why do we do this actually? rsync grep -e. Anyway, it has multiple options, but there is one to execute system commands, which is -e, -d, where is the -e? rsync -e, missing an argument. Why I'm not being able to find it? Remove source files. This is the grep, by the way. rsync. Yeah, it's getting boring actually. I'm gonna skip this now. Alright, so where were we? We were at the cron tab. So also there is the use of the asterisk or the wildcard. So what it does, why they use the wildcard? They use the wildcard to apply the command at all files in this directory, or here, var.html portal config. So rsync now will be applied on all the files since it uses the wildcard. So what does this mean? If we create our own file and place the file under portal config, what's gonna happen now on the next when the job is running, it's gonna go over all the files, including our file or the file that we created. Assumingly, it's gonna copy the file to the /backup. That's one, all right? So we can make rsync takes a file of our choosing, a file we create, and make it as one of its command line arguments, all right? Okay, that's fine. The next step is to harness the fact that there is an option in rsync -e or a switch -e that allows us to execute system commands. So all of this boils down to one thing. We can create now a script under this directory /var www.html portal config. The script, we can let rsync execute it. How this goes? Okay, let's first go to this directory cd ls. So we have these files. What we can do now, we can create a file called shell.sh. Before we create this file, we're gonna need to decide what are the contents, what will be the contents of this file. The content of this file will be to execute bash shell, right? The bash shell will be executed by rsync. So namely, shell.sh will be executed by rsync. I'm gonna show you guys how rsync will be able to just execute shell.sh. But now let's stick to the point or the idea. What will be the content of shell.sh? The shell.sh, first we can use echo, and here between the okay, so start the first one. It's not a responsive shell. So cp bin bash home plot admin and name it as plot shell. The first thing, I'm copying bin bash to a new file called plot shell. Exists under the plot admin directory, the home directory of the target user, which is here. All right, that's the first thing. Next thing is we give it execution permissions and the suite bit set, so that when it executes, it will execute under the user plot underscore admin. Home plot admin plot shell. So that is the content of the shell.sh that I will create. I'm gonna now direct all of these to output file called shell.sh. Now cat shell.sh. These are the contents of this file. Now shell.sh up until now will be just a regular file that rsync will try to copy into backup, since it has the asterisk or the wildcard. So how can now we make rsync execute shell.sh? We need to supply the option -e to rsync. But how do we do that? We need to take advantage of the fact that it uses the wildcard. Since it uses the wildcard, it takes all of the file names here under this directory, all of them and makes it as the arguments, right? As arguments in the command. So now config goes here, services goes here. Okay, so what if we make a file name? The file name goes like that, -e, all right, sh shell.sh. So this one will be a file name that we create. Once rsync is running, this one will be replaced instead of the wildcard, and we successfully provided the -e. We can successfully provide a -e as an option, and the arguments are sh shell.sh to execute the shell script we created. So, but how to create such file name? We can use touch -e, use double quotes, and -e sh shell.sh. But we have a problem here, as you can see, invalid option --. So we need to provide a -- here, -- and then the file name -e sh shell.sh ls. So now we have created the file whose name is -e sh.shell.sh. What's gonna happen now, as I told you? Once the cron job runs, rsync -t wildcard. The wildcard will be replaced by what? Yeah, all the files, but we also will take this one. This one we interpret it as option in rsync to execute system command. The command will be sh.shell.sh. What's gonna happen now? It's gonna execute this one. Once this is executed, it will copy the bin bash to a file called plot shell and gives it execution permissions along with the suite bit set. So now what do we have to do now? We have to wait for the cron job to run and navigate to home plot admin. If it was successful, you would find the plot shell created, and you will be able to execute it and gain plot admin access. Let's go now to home plot admin ls, and indeed there is a file called plot shell. Let's take a look. ls-la. As you can see, the plot shell has been created under the user plot admin, right? It has the suit bit set. Also, I have the user flag, which I missed before. Permission denied. Very good. Yeah, of course, because as you can see, the permissions are different for the user. So now what I can do, I can execute the plot shell and gain plot admin access. Plot shell -p id, who am I? So right now I am plot admin. All right, let's stabilize the shell. I hope Windows Defender, okay, Windows Defender now allowed me to open the file. That's good, because usually it just quarantines this file, the reverse shells. TTY, let's take this one. Python. How about Python 3? Alright, fine. Okay, that's fine. Who am I? I am plot admin. pwd home plot admin ls. Okay, cat user.text. And here is the user flag. Let me copy the user flag. Provide what was missing. Okay, fine, thank you. Alright, back to the challenge. Now we are plot admin, but you know, this isn't enough. We need to be root. So the next thing on the table is to exploit the Perl script. So again, if you run linpiece, alright, linpiece will point you to the right direction and will tell you that there is a Perl library running, and this Perl library shouldn't be running actually, or shouldn't be added as a capability to the Perl language or to Perl installation in this machine. So if you use now get -r dev no, see the list of capabilities. I'm getting now failed to. All right. Get cap-r. I'm getting now the list of capabilities. So all directories to dev null. Let's see the list of capabilities in here. Okay, here it is. User bin Perl cap founder. When cap founder is enabled, we can let Perl execute commands. Now, the exact commands that you can execute when cap founder is enabled is to change permissions of files and directories. So what you can do here, you can use Perl to change the permission of the root flag. But since we're doing this from the purpose of the real pen testing, we're going to need to take the root shell, gain the root shell. So how to do this? We can let Perl change the permissions of the binary bin bash, all right, and make that binary execute as root. How to do that? So user bin Perl. Now -e, we specify a command to execute. You can also take cap founder and go to Google, say Perl cap founder exploit. Privileged escalation. Take a look at this one. And here we'll run through all of these lines. Say chmod. Perl. There it is. So -e to execute system command. You specify the command in here, like that. but we won't do this one. What we're gonna do, we're gonna change the permissions now of the bin bash binary. So chmod, say 04777. I specify the binary that we would like to change the permissions of. So bin bash. Okay, here it is. Enter. Alright, now we execute bin bash. Or let's say, yeah, execute it. Bin bash dash p id, who am I, and now we are the root access. We are the root user. cd root ls cat root.txt, and this is it. So here you go, guys. I hope you found that informative, and we definitely will see you in the next video.